When most people picture a tornado, they imagine a massive, isolated funnel cloud churning across the plains. But there's a sneakier threat: squall-line tornadoes. These tornadoes hide in messy lines of storms, often invisible and shrouded in rain. You don't see the classic cone, just sudden destruction. They often strike at night, catching people off guard. New technology is helping us spot these hidden threats. Knowing about squall-line tornadoes is the first step to staying safe. When the skies turn dark, knowledge is your best defense. So, what exactly is a squall line? It's a long, organized line of thunderstorms. Think of it as a meteorological army front, advancing across the land. Meteorologists call it a quasi-linear convective system, or QLCS. These lines can stretch for hundreds of miles, producing widespread wind damage, heavy rain, and frequent lightning. But hidden within that chaos is the potential for tornadoes. Squall lines form when warm, moist air near the ground meets colder, drier air above. An unstable setup. A trigger, like a cold front, forces the warm air to rise, forming towering storm clouds that organize into a line. The real danger is at the leading edge, where powerful updrafts and downdrafts collide. Here, turbulence and wind shear can create small-scale rotations, called mesovortices. If one of these tightens and reaches the ground, a QLCS tornado is born. Unlike supercells, which are single, massive storms, squall lines are collections of many storms working together. The tornadoes they produce are quick, often lasting just minutes, and can be nearly impossible to see. The entire system moves fast, sometimes 40 to 60 miles per hour, leaving little time to react. These tornadoes aren't the main event, which makes them easy to miss. But their rapid evolution is what makes them so dangerous. In a squall line, the threat is hidden, fast, and relentless. That's what makes these storms so deadly. Comparing squall-line tornadoes to supercell tornadoes is like comparing a pack of wolves to a lone grizzly bear, both dangerous but in very different ways. Supercell tornadoes form from a single, massive, rotating storm and can be tracked for long periods, giving people time to take shelter. The threat is visible and relatively predictable. Squall-line tornadoes spin up quickly from small circulations called mesovortices, often hidden in rain and hail. The only warning might be a sudden roar or flying debris. Supercell tornadoes cause the most violent, long-track events, while squall-line tornadoes are usually weaker, but strike with little warning. Both are deadly, but squall-line tornadoes are the ultimate sneak attack. Forecasting squall-line tornadoes is one of meteorology's toughest challenges. Two key ingredients: wind shear and CAPE. CAPE, convective available potential energy, is the fuel for thunderstorms. Supercells thrive on high CAPE, but squall-line tornadoes often form in high shear, low CAPE environments. Wind shear, changes in wind speed or direction with height, creates rolling motion in the atmosphere. The storm's updraft can tilt this roll vertically, forming mesovortices that can become tornadoes. These conditions are common in winter and early spring, when jet stream winds are strong. The hardest part for forecasters? Pinpointing exactly where and when a mesovortex will form, along a squall line that could be hundreds of miles long. We can issue broad tornado watches, but specific warnings are tough. These rotations are small, fleeting, and buried in chaos. By the time a warning is issued, the tornado may have already touched down or dissipated. It's a race against the clock, with lives on the line. That's the forecasting nightmare of squall-line tornadoes. While tornadoes can happen anywhere, the southeastern U.S., Dixie Alley, is ground zero for squall-line tornadoes. States like Mississippi, Alabama, Tennessee, Georgia, and Louisiana face a longer, more complex tornado season, often peaking in the cool months. High shear, lower CAPE, and abundant Gulf moisture create perfect conditions for squall lines. The Southeast's hills, valleys, and forests block views and radar, making tornadoes even harder to spot. Unlike the open plains, these storms often strike at night, when people are asleep and unaware. Population density and vulnerable housing, especially mobile homes, add to the risk. Here, tornadoes are more likely to hit towns and cities, not just farmland. The combination of frequent cool season events, nocturnal storms, tough terrain, and vulnerable communities makes Dixie Alley especially deadly. The storms aren't always stronger, but the circumstances make them far more dangerous. That's why research and better communication are so critical in this region. For the southeast, the roar of the wind at night is a constant, terrifying threat. And it's a threat that demands respect. The dangers of squall-line tornadoes become real in the aftermath of major outbreaks. The Super Tuesday outbreak of 2008 saw deadly tornadoes embedded in a massive squall line, striking after dark and catching many off guard. In 2012, a powerful squall line swept across the Ohio Valley and southeast, spawning brief but intense tornadoes that devastated towns like Henryville, Indiana, and West Liberty, Kentucky. The Easter 2020 outbreak brought a massive squall line from Texas to the Carolinas, with rain-wrapped tornadoes causing widespread destruction, often at night. These events share tragic themes. They happen fast, often at night, and the tornadoes are nearly impossible to see. Warnings come with little lead time, and the psychological toll on survivors is immense. The feeling of being hit by something you couldn't see coming is a unique trauma. These real-world disasters drive the urgent push to better understand and forecast these sneaky storms. The impact isn't just measured in destroyed homes, but in lives changed forever. Squall-line tornadoes are not just a theoretical threat, they are a deadly reality. And their unpredictability is what makes them so dangerous. That's why every minute of warning counts, and why we must keep pushing for better solutions. Scientists aren't standing still in the face of this threat. The Perils Project, Propagation, Evolution, and Rotation in Linear Systems, is leading the charge to understand and predict squall-line tornadoes. Perils puts researchers and cutting-edge equipment directly in the path of these storms, especially in Dixie Alley. Mobile Doppler radars, weather balloons, and ground sensors collect real-time data as squall lines evolve. The goal: uncover the subtle clues that signal when and where a mesovortex will produce a tornado. By sampling the atmosphere just before storms hit, scientists can connect pre-storm conditions to what actually happens on the ground. This data is revolutionizing computer models and improving forecasts. Perils is already changing how we think about these storms, revealing why some kinks in a squall line produce tornadoes while others don't. It's dangerous, high-stress work, but the payoff is enormous. Better data means better warnings, and more lives saved. The front lines of science are making a real difference. While field research is crucial, radar technology is transforming how we detect tornadoes in real time. The upgrade to dual polarization radar, dual-pol, has been a game changer. Unlike standard radar, dual-pol sends both horizontal and vertical pulses, revealing not just where rain is, but the shape and size of objects in the air. This allows meteorologists to distinguish between raindrops, hail, and tornado debris. The key breakthrough: the tornado debris signature, or TDS. When a tornado lofts debris, dual-pol detects it instantly, even if the tornado is hidden in rain. This gives forecasters high confidence to issue urgent, specific warnings. A confirmed tornado is on the ground. For QLCS tornadoes, often invisible to spotters, this is revolutionary. It closes the gap between detection and warning, saving precious minutes. Now, even the sneakiest tornadoes can't hide from radar. Technology is helping us fight back against the hidden threat, and every second counts. Dual-pol is saving lives. Squall-line tornadoes are fast, stealthy, and often underestimated. They challenge forecasters and terrorize communities, especially in Dixie Alley. But science and technology are catching up. Projects like Perils and advances like dual-pol radar are giving us new tools and better warnings. Still, the most important defense is awareness. Know that a line of storms on radar can hide tornadoes, especially at night. Take every tornado warning seriously, even if you can't see a funnel. Have multiple ways to get alerts: weather radios, apps, local news. Make a plan and know your safe place before storms arrive. The story of squall line tornadoes is about bringing hidden danger into the light. We're learning to anticipate their moves and respond faster. When the next squall line approaches, remember, knowledge and preparation save lives. Your safety depends on it.